Welcome to my lecture on omitted measurements. It is not uncommon that a surveyor doing a traverse is confronted with a situation wherein field observation of the length or direction or both of a line or lines is not possible. One case is that for a traverse, the distance and direction of one course is not known. In another case, it is possible that the distances of two adjoining or adjacent lines are not known, or possibly the directions of two non-adjoining sides are not missing. Now, luckily, these quantities may be determined analytically. The only trouble with these calculations is that this tends to disregard all the possible mistakes and errors that might have been committed in the observations of the other quantities in the traverse. Hence, our adoption in adopting the computations that we will make is that all other quantities considered are true and accurate. Let us now consider the simplest case wherein the distance and direction of one line are missing. So we have here a traverse comprised of 5 station points, and let us say that side CD has a missing length and direction. Could be a bearing or an azimuth. So what we are going to do is we simply apply the condition for any closed traverse. That is, the sum of the departures must be equal to 0, and the sum of all the latitudes must also be equal to 0. Okay, with this, we'll be able to determine the latitude and the departure of line CD. So, we add departure of AB plus departure of BC plus departure of CD plus departure of DE plus departure of EA equal to 0. Same thing for the sum of the latitudes. So, knowing the latitude and the departure of line CD, we'll be able to calculate for its length by simply taking the square root of the sum of the squares of the latitude and departure of the missing side CD. As for the direction, we calculate for alpha, which is arctangent of the departure all over the latitude. Let us now work on a problem. We are to complete the data for the given traverse. Our traverse is comprised of 4 traverse lines, and both the length and bearing of line CD are unknown. Okay. Let us now create a table for the latitudes and departures of the courses comprising our traverse. So we have the latitudes and the departures of the sides AB, BC, and DA. Now, the latitude is determined by simply multiplying the length to the cosine of the bearing, and the departure is equal to the length times the sine of the bearing. So as for the solution, we start with the summation of the departures equal to 0. So departure of AB plus departure of BC plus departure of CD plus departure of DA equal to 0. We substitute the values. Then we'll be getting the departure of CD equal to negative 411.33. For the sum of the latitudes equal to 0, that will be equal to the latitude of AB plus latitude of BC plus latitude of CD plus latitude of DA equal to 0. Substitute the values of the latitudes of the known sides equal to 0. Then the latitude of CD is negative 873.19. We then determine the length of side CD by adding the squares of the latitude and departure, and then we extract the square root, and that will give us 965.22. To determine the direction, we calculate for alpha, which is the arctangent of the departure of CD all over the latitude of CD, and that gives us 25 degrees and 13 minutes in the direction southwest, no? Because the latitude is negative and the departure is also negative, so it takes on a southwesterly direction. And so that completes our solution. So here is the completed table for our traverse. Thanks for listening.